Math, it's all about math, the wonderful world of math. Welcome to the wonderful world of math. Today, it's trigonometry time, double angle identities. And for the first double angle identities, we want to talk about how to derive them, because being able to derive them is an important tool for somebody who wants to understand how to use identities. So what we want to do is we want to take the sum angle formulas for sine and cosine and tangent, and we want to turn these into what we call the double angle formulas. So first, let's recall all of the sum angle formulas. Sine of a plus b is sine of a times cosine b plus sine of b times cosine a. We got two angles, and here you have two terms, one term, a second term, and each term has two factors, a sine and a cosine. Sine of one angle, cosine of the other. Sine of the other angle and cosine of the first. Right? Okay. So two terms, and each one has mixed sines and cosines. Cosine of a plus b is two terms. It's a product of two different cosines, minus, notice that plus and plus, same sign, plus and minus, different signs. Product of two different cosines minus product of two different sines. Yeah? Okay, and tangent. Tangent of a sum of two angles was tangent A plus tangent B over 1 minus the product tan A tan B. What we're going to do, one at a time, is we're going to take this and turn it into twice an angle. We want to find the sine of 2 times some angle. So let's say 2 times A. Well, the thing about multiplying by 2 means something plus itself. For example, 2A means A plus A. 2 bananas means banana plus banana. So if you know that 2A means A plus itself, then it's going to start to look a lot like this. The thing about sine of 2A, once you know that it's really sine of A plus A, it's just the sine sum angle formula where A and B are the same angle. So imagine you replaced all of these B's with the letter A. What would you get? Well, you would get sine of the first angle, which happens to be A, times cosine of the second angle, which now also happens to be A, plus sine of the second angle, which happens to be A, and cosine of the first angle, which is A. Color coding that, we see the first angle, which we've colored blue, and the second angle, which we've colored purple. If they're both the same one, we can see where they used to come from, right? But it's still just sine A and sine A. They're the same. So you see sine A, cosine A, and sine A, cosine A are actually like terms now. So coming back to it, banana plus banana is 2 bananas. When I add sine A, cosine A plus itself, I get 2 times sine A, cosine A. And this was all equal to sine of 2A. This is the sine double angle formula. And the way we got it was by taking the sine sum angle formula with the two angles being the same. So given that secret, see if you can find the tangent double angle formula and the cosine double angle formula. Go ahead and pause this and give it a shot, and then start me up when you're ready to check. You ready? 3, 2, 1. Here we go. Tangent 2A means tangent of A plus A. The tangent sum angle formula said tangent of A, the first angle, plus tangent of the second angle, also A in this case, over 1 minus tangent A, the first angle, times tangent of the second angle, also A. But these are like terms. Banana plus banana, 2 bananas. 2 tan A. And in the denominator, tangent A times itself, well, plus yourself means a coefficient of 2. Times yourself means an exponent of 2. This means tangent A parentheses squared, or tangent squared of A. This is the tangent double angle formula. Cool. So I hope that was the same thing you got, and that's what we're supposed to get. The cosine double angle formula, did you get that one yet? If not, here's your chance. 3, 2, 1. This is cosine of a plus itself, a plus a, so that the first and second angle, both a. Cosine sum angle formula says cosine of the first times cosine of the second, both a, minus, plus, minus, opposite signs here for cosine. Sine of the first angle times sine of the second angle. But because these are the same, something times itself means squared. Something times itself, squared. So this is cosine of a, parentheses squared, or cosine squared a, minus sine squared a. This is the cosine double angle formula. But wait, watch out. There are actually 3 cosine double angle formulas that we use, because calculus needs all of them. We're going to use 2 more, but you can go ahead and put a box around this one. This one is the first and foremost cosine double angle formula. Okay, are you ready for the other ones? All we're really going to do is use the Pythagorean identities to turn these cosines into more sines for one of them, and for the other to turn these sines into more cosines. So let's take the very first Pythagorean identity, the fundamental identity, if you will, and we will. This is sine squared a plus cosine squared a equals 1. Now, we had some different versions of this. We said I could take both sides subtracted by cosine squared, and this would give me an equivalent, different looking identity. Cosine squared minus cosine squared cancels on the left, and on the right we get 1 minus cosine squared. So this gives us a way to write sine squared in terms of cosine squareds. So let's look at the cosine double angle formula again. Cosine of 2a equals cosine squared a minus sine squared a. But now we have an expression for sine squared in terms of cosines. I can replace this with that. This is probably the harder of the two, because I'm taking something that used to be one term, sine squared, and instead of subtracting one term, I'm now supposed to subtract these 2 terms. So the hard thing is to remember that since I'm subtracting a group, I have to use parentheses. That cosine squared a minus parentheses 1 minus cosine squared a becomes cosine squared a minus 1 plus cosine squared a. We have to distribute that minus in front of the parentheses, so that cosine squared plus cosine squared, something plus itself, common theme of this video, banana plus banana, 2 bananas. 2 cosine squared a minus 1. This is one of the 3 cosine double angle formulas. This first row here being the first one, and this is another one. So we'll put a box around that. So here we're going to do the one we didn't do last time. Last time we subtracted both sides by cosine squared. Now we're just going to subtract both sides by sine squared of a. And you'll get cosine squared of a equals 1 minus sine squared of a. It should look pretty similar to what we had last time. Now when I take cosine squared a minus sine squared a, we know that this is cosine of twice a, or 2a. But this time, I'm going to replace cosine squared with this expression in terms of sine squared. So this becomes 1 minus sine squared. But because of its position in the front, those parentheses don't really mean anything in particular. They're just there to see that grouping, that visualization of us plugging it in. So we can just drop them, right? Now we've got a negative sine squared and a negative sine squared. They have the same sign. So they're both going to get to be a bigger negative number. The coefficients, negative 1 and negative 1, when I add them up, negative 1 plus negative 1 is negative 2. So cosine 2a is equal to this also. So there we go. These are the 5 double angle formulas, the one for sine, the one for tangent, and the 3 for cosine. And this is how we got them. We used the double angle formula where both angles were the same. A plus A is 2A. Stay tuned for our next video in the series where we actually use examples of what to do now that we have these, and then later when we use these to get the half angle formulas. Woo! So our word of the day is Telmatosaurus. Hey Telmatosaurus, what's Telmato with you? Nothing. What's Telmato with you? It's the swamp lizard. Telmatosaurus. This has been a Badger Bear production of The Wonderful World of Math.